Hello and welcome to our session about lean operations, also known as just-in-time operations. This is chapter 15 in your operations management book, and this is part of the QDC1 course. So what is lean operations? Lean operations means a flexible system of operation that uses considerably less resources than a traditional system. And what this comes down to is that it's a very, very efficient system that focuses on eliminating waste, using an optimized amount of inventory, and that's why it's also known as just-in-time system, because you produce and you use the resources you need when you need them. They tend to achieve greater productivity, lower cost, shorter cycle times, and higher quality. And the higher quality is a very important pillar of lean operations because one of the philosophies behind lean operations is that if you have very high quality from the get-go, then you're going to be able to reduce your operational costs by just by the fact that you don't have to go and fix products, remanufacture products, and everything is almost perfect or and most of the time perfect to a degree where you really don't have to worry about anything after you finish manufacturing. Lean operations were developed in Toyota in Japan. Initially, they actually did take a lot of the concepts from the United States, but this grew into a very Japanese way of doing manufacturing. Even though today just-in-time operations, also known as lean operations, have been duplicated all over the world, still it is a very, very Japanese way of manufacturing, and let's go over a few of the basic concepts. As you can see, all the names are all the words are in Japanese. I don't speak Japanese, so forgive me if I'm not pronouncing it correctly. But let's go over these key terminologies so you can get an understanding of what are the basic concepts of lean operations. So muda, which means waste and inefficiency, is that's the number one concept of lean operations. You want to eliminate waste and you want to eliminate inefficiencies. And by waste, you mean inventories, for example. And you can say, why is an inventory a waste? Because inventory takes space. It takes time to process it. It's wasteful in terms of keeping your operation as lean as possible. Inefficiencies are disruptions to the system, lower quality. All these things you wanna eliminate them and be as efficient as possible with the lowest cost possible in terms of productions. Kanban, which goes together with pull system, is a manual system that signals the need for parts or material. And let me first explain what pull system is, and then you'll understand what Kanban means. A pull system is exactly the opposite from traditionally what you think about manufacturing. So in a traditional manufacturing system, also known as a push system, what you have is you have a system where every workstation pushes its output to the next system. And by doing so, basically, when I get the products, whatever I get, the unit, the work in process product, I work on it, I do whatever I need to do on it, and then I push it to the next station. So the entire system is always one system, one workstation pushing the products to the next system until you get to the end where the product is finished. With a pull system, it's exactly the opposite. What happens is that when I need you to produce parts for me or give me materials, I signal you using a Kanban system that, hey, I'm about to finish my production. I'm at a point where I need you to start working on your parts, or I need you to start working on getting me material so I can continuously work. So it's a different way of thinking about operations in terms of manufacturing. Heijonka, I think that's how you pronounce this, means workload leveling, and that's again one of the important aspects of lean operations is that you want all the workstations, all the workers, all the overall system to be a balance. You don't want to have bottlenecks. You don't want to have a system where some workstations are working a lot harder than other stations, and then you start creating a situation where it's an unbalanced system. So it's very, very important. And this is a very, again, a very Japanese philosophy, which is, it goes way beyond just manufacturing. Kaizen, which you will also hear if you study total quality management and quality management in general, is the Japanese concept of continuous improvement of the system. And what does it mean? It means that instead of having those big changes that, if you think about Western type of management, there's always a big change. Changes are never small. It's always the system-wide change that needs to happen tomorrow. In Japan, that's not going to work. And what they do is that they do small changes, small improvements to to the system, but it continuously. You always improve the system. You never stop and say, okay, now it's perfect. I don't need to do anything. And I like the way I like to explain this is that. You know that adage where people say if it's not broken, don't fix it? The Kaizen adage would be if it's not broken, it doesn't mean you can't improve it. Jaidoka means quality at the source, at the worker, and the idea here is that the responsibility for the quality of the product is not left for some department, the quality assurance department, at the end of the process that goes through everything, checks it, and then decides if it meets standards or not. Quality at the source means that the responsible for the quality of the products is at the source, at the person who is actually manufacturing the product. And what's interesting about it is that it gives the worker, an assembly line worker, the lowest level worker in terms of the manufacturing process, full responsibility for the quality. And in Japan, if you go to an auto factory, an assembly line employee can stop the entire production if they think that there's an issue with the quality of the product. That's how much power they have, and that's how much responsibility the organization puts on quality. Pokayoke means safeguards that are built into a process. And to give you an example, if you design a product in a way that the parts can only fit together in one way, there aren't two ways to get the parts together. So you really can't screw it up. You can't put two parts in a way that later on is going to be a problem, and that's a safeguard that you build into the design. Another good example of a safeguard is, for example, if you let's say you're manufacturing something, and at some point there has to be 4 parts. I mean, if you have 3 parts, then something's wrong. So you create this box, let's say a carton box that has 4 holes, and each hole is exactly the shape of the part that you need. So in terms of working on that station in the factory, you can't miss it. You have this safeguard that immediately visually shows you that you missed something in the process. Team concept is the use of small teams of workers, but a very cohesive teams. Everybody, in order for lean operations to work, everybody has to be in balance. Everybody has to work together. It's not going to work if you don't have a cohesive team working together to make sure that you really are as efficient as possible. So the goals and building blocks of a lean system. The ultimate goal is to have a balanced, rapid flow, super efficient, with the highest customer satisfaction. That's the ultimate goal. The two supporting goals are eliminating waste, and like I said, that's one of the most important aspects of a lean system, to make sure that you have exactly what you need, and everything that is not relevant to the production is taken out. And the other supporting goal is eliminating disruptions. You have to make your system flexible. So eliminating disruption is the concept that you want to minimize the amount of time that the machines that you have to spend when you want to realign machines to work on a different product, right? A factory is not manufacturing just one product. It might manufacture hundreds of different products, tens of different products, but anyway, anytime you change those machines to work on a different product, you want that to be minimized. You want to make sure that quality is high, so you don't have to go and reproduce stuff. the idea here is that with a lean system, with a very cost-effective system where everything is really exactly when you need it, like just in time, any disruption is going to basically stop the entire system. And especially when you're talking about eliminating inventories, because if you eliminate inventories, then you don't have that buffer if a machine goes down for the next machine to be able to work. So it's really, really important to make sure that everything is working as smoothly as possible. Now, how do you achieve these goals? You have four building blocks, which we're going to focus on later in the presentation. Give a dedicated slide for each one of them. You have the product design, the process design, the personal and organizational elements, and you have the manufacturing, planning, and control. So, to sum it up, what are the main supporting goals and aspects of lean operations? One, eliminate disruptions. Remember, any disruption in the system is going to make it very difficult for the system to be efficient if every day you have to stop it because something's not working, because the machines are stuck, because people are not doing what they want to do. It's just not going to be lean anymore. You want to make the system flexible, so the system has to be such that you don't have to waste a lot of energy and time moving between different production. Everything needs to be flexible and smooth so you can keep yourself lean. And the third goal is to eliminate waste, and especially inventory. And we'll talk about it more later. So let's go over the building blocks of a lean operation system. Product design. So how do you design a product so it fits into a lean system? First of all, you want to use standard parts, and that makes total sense, right? Because if you're using all really parts that are completely unique and non-standard, then you're putting a lot of risk into your system for disruptions. You're basically making a process that is very, very hard for you to put people into to make sure that you can control it, because the parts that you're using are non-standards. So really the idea here when you design your product is you want to make sure that it's very easy for the system in terms of managing inventory, but also in terms of the employees and the level of specialization that they need to get to in order to manufacture your product is efficient and as simple as possible. And really, a lot of people who learn about lean operations think they're really complicated, but actually one of the main design aspects of lean operations is to keep everything simple. Don't overcomplicate stuff. Modular design means that when you design your product, you design it with different models that fit together. And what this gives you is it gives you flexibility in terms of manufacturing, but it also makes it very easy for you to control the quality and control the flow of production, because you have these models that build a different product. If it's a car, you have these different models. The engine, the steering system, etc., etc. And they're built in a way that everything goes together like a Lego, like a puzzle. Everything is built together perfectly. Whereas a different way to design it would be to design it not based on different very distinctive models, but rather kind of like one big flow of a product. And the problem there is that it's much harder to design to control it, and it's much harder to produce it. Quality, you'll hear the word quality as part of just-in-time lean operations all the time, because it's such an important aspect. Quality, quality, quality. You want to design your product from the get-go to have the highest quality possible. You want to design it from the beginning, from the engineer sitting on a whiteboard, to make sure that it's in terms of the manufacturing process and in terms of the overall product, it's going to be the highest quality possible. Because if you have to go and remanufacture, if you have to throw a high percentage of your units because they're not high quality, or you have to deal with customers not being happy, you're not going to be able to keep a lean system. Concurrent engineering, every time you engineer and make a design change in terms of your product design, it's going to be a disruption, right? You're going to disrupt your system because you're making these changes. Concurrent engineering is the idea to make your engineering and you make your design such that any adaptation, any improvements are easily integrated into the existing system. Process design. So now you design your product, thinking lean operations in your mind, and now you need to take and manufacture this, right? You need to make it into a real thing. So the next thing is, how do you design your manufacturing process so that it follows the lean operations methodologies. So first of all, small lot size. That makes absolute sense, right? Total sense, because you want to keep everything as lean as possible, and you want to reduce waste. So in terms of the lot size, meaning how much you manufacture at each cycle, you want to keep them small. Setup time reduction, also known as single minute exchange of die, means that amount of time it takes you to set up your machines to work on a different product. So let's say you have two products, product A and product B. In order for you to move your systems to now start manufacturing product B, you're going to have to do some changes on the machine, right? Because if you have one machine that has a quarter-inch holes and another machine that needs half-inch holes, you're going to have to go and change the drills on the machine to have a bigger diameter in terms of the hole. So there's always going to be some kind of change, but how do you minimize it? How do you make it as flexible and as quickly as possible? So the idea behind single minute exchange of die is that you take the machine and you look at how it operates and what you need to do in order to change it from working on product A to product B, and you group it into two types of changes: internal changes and external changes. Internal changes mean that you have to stop the machine. The machine needs to be idle in order for you to make that change. For example, if we're talking about the drilling stuff, then you have to go and change the drill bit from a quarter-inch to a half-inch. You can't do that while the machine is drilling. It's just not possible. You have to stop the machine, put the different bit into it, and then run the machine again. And then you have external changes. External means stuff that you can change with the machine in terms of setting it up, getting it ready to work on a different product without the need to stop it. Now, obviously, the more you have external changes that you can do while the machine is working, the better, because you want to minimize the amount of time that you absolutely have to stop the machine. So if you go through that, you find out by design and by working on the process that you can really minimize the amount of time it's going to take you to move your production from working on product A to working on product B. You can bring it to a minimum by making sure that you really have the least amount of internal changes within your machine, so that whenever you need to go, okay, now I need to start working on product B, most of the changes have already been done, prepared while the machine is working, because they are external changes. Manufacturing cells means that your group of manufacturing workstations are put into cells, which every cell is very specialized. Every cell knows exactly what they're doing, and all the cells are working harmoniously together. Everything is working in a modular, like we said, a modular design where everything connects to each other, and a beautiful flow, and a very efficient flow. Quality improvements, again, quality is such an important part of just-in-time lean operations, and definitely is part of the process. You want to always continuously improve your system. Always look for ways to make the process better and more efficient and more lean. Production flexibility, we just talked about it, about the setup time reduction, but in general, it's not just about how long it's going to take you to change your machines to work on product A to work on product B, but in general, you want your entire production to be as flexible as possible. So your ability to move between products and to integrate changes into your lean operations are as smoothly as possible. A balanced system, we mentioned it before, you need everything to be harmonized. You want all the workstations to work in terms of workload leveling to be about the same. You don't want to have any bottlenecks. As little inventory storage as possible. And remember, in lean operations, inventory is considered a waste. You want to have the exactly amount of inventory you need in order to manufacture. You don't want to have a huge warehouse with tons and tons of inventory. Fail-safe methods, we already spoke about it in terms of the design, how you design it. so that for example, that parts can only fit in one way. But also in terms of the process design, the methods should be fail safe. And that, I gave the example of having a box where the parts need to go into, but really making sure that the process itself, the way you design it, is such that it's very easy for you as as an assembly line worker, as anybody anybody in the factory, to immediately see that something is wrong, something is not fitting the way it should fit. Personnel and organization elements. The human factor is, I believe, is the most important factor in any production process. But in lean operations, that is very, very, very important, because in order for this to work, in order for you to have such an efficient system, everybody needs to work together. If people don't know what they're doing, if people are not on board, and they don't and they're not cross-trained and committed for continuous improvement, it's not going to work. You have to view your workers as an asset, and you have to have a different type of leadership and management. You have to have the type of manufacturing management where it's not just about whipping your workers, everybody go to work. It has to be about working together as a team and being open to suggestions and quality improvements. For example, if you don't have an open type of leadership where employees feel comfortable telling you that they think there's a way to improve the system, or that there's an issue with the system, then nobody's going to talk to you, and then you're missing one of the most important points of lean operation, which is the continuous improvement and the high quality. Manufacturing planning and control. So we spoke about the level loading of all systems, the pool system, which now kind of makes more sense to you, because you think about it. You want to pool stuff. You want to be the workstation needs to be the workstation, the point that tells the preceding workstation that it needs production, and that way you never have waste. You never have excess inventory, because everybody's always asking for exactly what they need. Visual systems is again a very important part of the manufacturing planning and control aspects of lean. Is You want to make sure that the systems are such that you can very easily visually identify when there's an issue. And I'll give you an example. In Japan, in the factories, they'll have these three lights: red, yellow, and green, which indicate if a workstation is in trouble. That's red. Yellow is about to get into trouble, and green, everything is fine. So if you go to the factory, and you kind of you have a bird's eye view, visually it's very easy for you to see when and if there are issues with the system. And remember, the lean systems, they need to be simple, and that in order for this to work, you need to be able to have an overview of the system very fairly quickly. Otherwise, if it becomes so complicated that you can't even know what's going on in each time, then it's going to be very hard for you to improve the system, but also to fix issues if you have issues. Limited work in process. Work in process means that it's an unfinished product. So the product is a work in process, and you want to minimize the amount of work in processes, or the amount of different stages that you have in terms of the production of a unit, so that the system can be, again, lean and efficient. And really the logic behind this is that if you have a lot of different stages that the product needs to go to, you're going to need to have a lot of inventory, even if it's a minimal amount of inventory. But still, if I have a pencil that goes through 5 different stages, every stage I need to do something to the pencil. The people who are working on manufacturing this pencil need to have inventory next to them, right? They need to have the stuff that they need in order to finish their part of the process. So you want to minimize those work in process stages, and make sure that you're also able to, by doing so, to minimize your amount of inventory, and to make sure that the amount of complexity that you put into the system is minimized. Close vendor relationships. Without a close vendor relationship, a lean system can't work, because unlike a traditional system where you buy huge amounts of inventory from your vendors, and you have stocks, and You can change your vendors, not super easy, but fairly easy because you always have uh, theoretically you always have enough inventory to be able to have a huge buffer. This is not going to work in a lean just-in-time system because you have to have continuous delivery of stuff from your vendors, and you also, because you want everything to be the highest quality from the get-go, you have to trust them. I mean, if you have to check everything that your vendor is bringing you, if you don't have a close relationship, you can't trust them in terms of the highest quality of their materials or services, then again, you're missing the point of being lean. So close vendor relationships, very, very important. Preventive maintenance and housekeeping, it's better for you to make sure that the machine is always in good shape and do preventive maintenance than wait for it to break and then fix it. And this goes back to, you need to minimize the amount of disruptions in your system, because every time you disturb the system, every time you stop the manufacturing process at one unit, you're probably stopping the entire process, because this is such a lean, such an efficient process. You really can't afford to have machines break down. Housekeeping is a very it's a very Japan thing. It's a very Japanese thing, and I want to talk about it. We already spoke about the benefits of a lower work in process. Go to housekeeping. So housekeeping is the idea that as a worker, you have to, in your own station, be lean and efficient. It's not just about the whole factory. It's also about you personally, and how you manage your own workstation, if it's on the assembly line or if it's sitting at a desk in a factory, or in a service-oriented type of business. And they have 5 S's for housekeeping. Sort means you sort your workstation. You sort where you work, where you produce your work, and you sort out all the waste. You make sure that only things you need are on your table or on your workstation. Everything else that is not relevant to the manufacturing process, you just put it away, which I know wouldn't work for my desk. I have tons of stuff on it all the time that I don't necessarily need. But if I was to work in a lean operation, I would have to sort it and only have stuff on my desk that I need. Straighten means that, okay, now I sorted, I only have the stuff that I need. The next step is for me to arrange them in the most efficient way. So if the things that I need to use most, the things that are the first things I'm going to use as part of the process of manufacturing, are going to be closest to me, and etc., etc. Sweep means to keep your working area clean, 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 clean. No waste. So it means not just not having excess inventory. It also means no actual waste, keeping everything clean and tidy. Standardize means use the standards, ways of operations that you've been told. So in one end, you want to have continuous improvements, and you want employees to tell you when something is wrong. But on the other hand, you want your employees to use the standard way that they've been told, because again, it's not, if everybody does whatever they want to do and they don't follow the strict process, then it's not going to work, obviously. And the last one is self-discipline, which again is a very Japanese way of thinking. It's putting the responsibility not just on some big manager out there, but also on you as the worker, to be self-disciplined and do what you're told, and have the highest quality and the most efficient way of doing things and thinking about the production. So lean versus traditional philosophies. I don't want to go over all of this, but in general, you can see that with lean, everything is small, everything is minimized, and really the if you look at these two types of production, traditional versus lean, the first thing that at least jumped to my eyes when I first was looking at this is that lean means lean everywhere. It's not just about a specific part of manufacturing. It's a whole philosophy of how to do business. Value stream mapping is a visual tool that that allows you to always examine the flow of materials and information. And in order for lean systems to follow the continuously improvement philosophy, they have to always visually map and collect information about what's going on in the production cycle right now, in order for them to gather information to see where they can improve. So they collect times and distance travels and the mistakes and methods and information. So basically, you have to gather information and in order for you to analyze it and come with improvements. So this is the last slide, and to sum up lean operations, um, just when you think about lean operations, remember that what the core philosophy of lean operations is and that's why they're also called just in time, is to have a system that produces what it needs to produce when it needs to produce it. And that every and of course every manufacturer wants to get there, right? Nobody wants to manufacture stuff they don't need, but in order for you to have a lean system, the idea is that it's a whole philosophical cultural change. That's why a lot of times companies get excited about lean operations, but when they try to implement them, it's a total failure, because it's not just about how you set up your factory. It's about a whole cultural philosophical change of mind, where you thinking lean from the top manager all the way down to the assembly line, to the design, to the process, to the control, to documentation, to everything. So lean operations are great, and they can really save you money, but only if you are ready and able to really immerse yourself and dedicate yourself to the concepts of being lean and efficient. I hope this helps. As usual, I also recommend to read the chapters on the book, because they have information that I might have not covered on the slides, and do the quiz on the book's website. They kind of help you gauge if you got the concepts or not. I hope this helps, and have a great day.